Hello everyone. In this video, we are going to discuss the topic of physical quantities and measurement. Our learning outcomes are physical quantities and SI unit. Let's begin by understanding first of all what is a physical quantity is. So physical quantities are quantities that are measurable quantities. So any quantity that we can measure is a physical quantity. Like, for instance, I say length of a rod or mass of a bag or volume of a cylinder. So we can measure the length, mass, and volume of rod, bag, and cylinder, respectively. So, all of these quantities, like if I say my height is 6 feet, my mass is 70 kilogram. So, all of these quantities that are measurable are physical quantities. So, how we express physical quantities? Let's say I have a rod, okay, and I'm saying that the length of that rod is 5 meter. Or let's say that I have a bag and the mass of this bag is 20 kilogram. So you see here that when we are expressing a physical quantity, we have a number like 5 meter, 20 kilogram, or like 10 meter cube of water in a cylinder, let's say. So you see here that I have a number followed by a unit in which it is measured. A number followed by a unit in which it is measured. So basically, a physical quantity contains a magnitude. All of these you are seeing here, these numbers are magnitude. Magnitude tells us the quantity, how much quantity of that particular object is that we are measuring. And this thing, the things on the right hand side, these things are the unit. So a physical quantities is expressed with a magnitude and a unit. Magnitude tells us the quantity and unit tells us that what we are measuring. If it is meter, so it is length. If it is kilogram, it is mass. And if it is, let's say, meter cube, then it can be or it is a volume. So a physical quantity is always written in this way. Now, let's discuss SI unit. So System International Unit is a unit that is followed in physics. And we have two types of units. We have base units and we have derived units. So let's start by discussing what is a base unit or what are base units. So base units, they are 7 fundamental units based on which all other units in physics are defined. So these are the 7 units, and any quantity in physics can be expressed in terms of these 7 units. They form the basic of physics, they are the basic unit of physics. So, what are they? There are 7 fundamental units. They are: number one, we have length. Okay, length is measured in meter and its symbol is a small m. Number two, we have mass. Mass is measured in kilogram and its symbol is kg. Number three is time. Time is measured in second and its symbol is capital S. Number four, we have temperature, that is measured in Kelvin and its symbol is K. Number five, we have electric current, and the the unit of electric current is ampere and its symbol is capital A. Then we have the intensity of light, and its unit is candela and denoted by CD. And last, we have amount of substance and its unit is mole, denoted by the symbol MOL. Small m o l. So these are the 7 units that you are seeing with their name and with their symbols, and all other quantities of physics other than these 7 are defined in terms of these quantities. They are known as the base quantities. If we talk about the quantities, length, mass, time, and if we talk about the units, they are the base unit like meter, kilogram, second, Kelvin, ampere, candela, and lastly the mole. These are all base units. Now let's move to the drive units. So drive units, they are expressed in terms of base units. They are defined either by the multiplication or division of base units. So we can find the drive units by the multiplication or by the division of the base units. So now, for example, velocity is a drive unit. So in velocity, the formula is displacement divided by time. So displacement is measured in meters and time is measured in seconds. So the unit of velocity is meter per second or meter second inverse. So you can see here very clearly that in this video And in this, in expressing the units of velocity, we are using two base units. One is meter. Meter is the unit of the length, the base unit, and the second is second, the unit of time. So you see, we are expressing the drive units in terms of either the division or the multiplication of base units. In a similar way, let's take one more quantity, acceleration. So acceleration is change in velocity over time. The formula of acceleration is change in velocity over time. So the unit of velocity, we know very well, that unit is meter second inverse, and the unit of time is second. If this second come upwards from downwards, so it will become meter second minus 2. So again, the unit of acceleration is derived or is expressed in terms of base units, is contained meter in it and it contains second in it, the two base unit. In a similar way, we have force. The formula of force is MA, and you can say the unit of force is Newton. But we have to express the unit in the form of base unit. Newton is a unit that is named, but it depends on some base units. It is equal to some base units because we can express any physical quantity in their base units. And that is what we are going to do in the past papers as well. The questions that examiner will give you, it will give you a question that express the units of these physical quantities in the form of base units. So force is equal to mass time acceleration. So we know the unit of mass will be kilogram, and the acceleration we have just derived, meter second minus 2. So the SI base units of force is kilogram, one of the base unit, meter, one of the base unit, second minus 2, one of the base unit. So you can see in this example that the drive units are expressed in terms of the base units. Either they can be found by multiplying or dividing by the base units. So that is about the drive units. Now in the final attempt, we are going to discuss, in the final topic, we are going to discuss prefixes. So in physics, we calculate very big or very small numbers. For example, size of an ant, a very small number, or distance from Earth to Moon, a very big number. So what we do, we uses the techniques of multiplier. So prefixes are basically, they are multipliers of unit. To express big and small number in physics. So how many prefixes we have? We have starting from pico, 10 is to power minus 12. Then we have symbol is a small p. Then we have nano, 10 is to power minus 9. Symbol is a small n. Then we have micro, 10 is to power minus 6. Symbol is a u here. Then we have milli, 10 is to power minus 3. Symbol is a small m. Then we have centi, that will be 10 is to power minus 2, and that will be small c. Then we have deci, and that deci will be, sorry, not deci, we have kilo, that is 10 is to power 3. Its symbol is k. Then we have mega, 10 is to power 6. Its symbol is capital M. And lastly we have 2. We have giga and tera, that is 10 is to power 9 and 10 is to power 12, and the symbol is capital G. Or a capital T. So if you see any of these kind of symbols with a unit, like if I write length of a rod is 3 centimeter, so you will simply multiply it by 10 is to power minus 2 because it is a unit multiplier. Or let's say if I write that the mass of a pen is 50 kilogram, so I can also write this as 50 into 10 to the power 3 grams. So these are basically multipliers. So let's say I say that the force is 10 meganewton. So you will simply multiply this number with a multiplier 10 is to power 6 Newton. So these are the unit multipliers, and that unit multipliers are used to calculate or to express very big and very small number in physics. So that's all for today's lesson. See you in the next video with a new topic.